In this video, I'm going to show you a visual demonstration on how to complete the mode method coming out of our statistics project. I think this is the hardest thing that we do in this class, just overall, but with the visual demonstration, I think you'll find it much easier. Here I have the documentation for our statistics project, and I'm looking at the mode method, right? This is in the statistics class. It is static, I can tell because this is underlined. The name of the method is mode. It is taking in a double array, and it is returning a double array. Mode should return a double array consisting of the modes of the specified array. The mode of a collection of values of an array is the value, the element that occurs the most in that array. It is possible for an array to have multiple modes, as numbers can tie for highest number of occurrences. Okay, so here is an example. Our first example, 13, which is highlighted in bold, is the clear-cut winner. It appears 4 times, and that's more than any other element, so we are returning 13. Specifically, though, note the brackets. What we're returning is a double array, and the only element is 13. Note that even though 13 appears multiple times, I only have 1 copy of it here in my mode. Down here in this next example, there's actually 2 modes. Right, because 13 appears 3 times and 14 also appears 3 times. And so we're returning a double array with just those elements. Again, note that even though 13 appears multiple times and 14 appears multiple times, I only have them here 1 time. In our last example, every element appears once, so that's what you get. Every element is effectively tied for highest number of occurrences, so that is the mode. So I'm going to dive into this. I'm going to basically note a little bit of pseudocode, I guess, my little visual demonstration on the left-hand side. There's going to be some array helper methods as we go that could be beneficial. Okay, so I'm going to use some numbers from our example. Sure. So what we're going to say is that coming into our double array, sorry, I should highlight this. Coming into our mode method is this double array, and I'm going to go ahead and call it values and actually paste this stuff in. Right? I'm saying that these are the values that are coming in. We'll use this as an example in our visual demonstration. The first thing that I want to do is figure out what numbers occur most frequently. In order to do that, I need to know how often do all the numbers occur. So I'm going to create a count array. The length of this array is going to be equal to values, the explicit parameter that's coming in. Because I ultimately want to count every element, right? So when you first declare that, it's going to be filled with a 0 for every element. This particular array has 1, 2, 3, 4. 9 elements, right? So when you first create this, it should have 9 zeros. Now what I want to do is actually go through values and count the elements. What I'm going to do is count each element and store the count at a corresponding index. What this allows me to do is create effectively a variable for each element, which otherwise wouldn't really be possible, right? This thing has a length of 9. I could, in theory, create 9 integers that will be my counts, but the length can vary. So the only way that you can really kind of create a variable amount of variables is through an array. So that's what this counts array is doing. I'm going to loop through values. With each iteration, I'm going to count how many times the current element appears in the entire array. Right? The current element being 13. Why don't we bring in integer I to kind of highlight where we're at. So I'm going to count how many times 13 appears. Let's see, 1, 2, 3, 3. I'm going to store that count at the corresponding index in counts. My I would increment. I'm now at 18. I'm going to count how many times 18 occurs in values. I see 1 occurrence. So I will store a 1 at the corresponding index in counts. I would increment. We're now here. I know I've already counted 13. I'm going to count it again. We got 3 occurrences, so I'm going to store 3 at the corresponding index. Right? I'm now here at 14. I'm going to count how many times 14 appears in the entire array. Let's see, 1, 2, 3 occurrences, so we'll store a 3 there. We'll end up going through this entire array, right, storing how many times the current element appears in values. So whenever I get done, if I want to know how many times 13 appears, I just get the corresponding element out of counts, and that is the number of occurrences. If I want to know how many times 16 appears, I just get the corresponding element out of counts, and that is the number of occurrences. Keep in mind we got double digits here, right? I could, in theory, align these things a little bit better. And you can clearly see for each number, I have an account associated with it. Okay. A potential array helper method is count. Count will tell you how many times a particular number appears in a particular array. That is one that we coded, right? What you would use it for is when you're looping through values, you would count basically how many times does 13 appear in values, and then you could store that count in your counts array. Okay, I'm going to get rid of this spacing. Okay, now that we have our counts, what I need to find is the maximum value in counts. The reason I want that is because the maximum value is the highest number of occurrences. What do I mean? I'm going to create max. Max is just a single integer. It is the largest value in counts. You can clearly see that that is a 3. Array helper method that could help us with that is a max method, right? Max is going to give you the maximum value in an integer array. Okay, so we would ask, what is the maximum value in counts? It's 3. Now what I want to do is go through counts. With each iteration, I'm going to ask, is the current element equal to my maximum? If it is, I'm going to get the corresponding element and store it into an array. So with that in mind, I'm going to create another array that I'm calling RTN because I plan on returning it. Now, actually, how about this? We'll call it modes. I'm going to call it modes because that's what it ultimately is. It is the one that I finally return, but it is our modes for the array. Now, the question I'm going to ask is, what is the initial length of this? What should it be? Well, let's think about this. What is the maximum number of modes that you could possibly have? We had an example over here where every element was a mode. And so that is our answer. It is possible that the number of modes is equal to the length of the original array. So I would create modes, and its length would be equal to the length of values. As it turns out, counts has the exact same length, so you could use either one of those technically. Right? That again is 9. Oh. I believe that is 9. Okay. So I'm going to say it again. I'm going to loop through counts. With each iteration, I'm going to ask, is the current element equal to my max? If it is, I'm going to pull it from values and put it into modes, but only if it's not already in modes. Okay, let's perform that. I'm going to go ahead and create I. Notice that because these things have the same length, we have arrays that basically line up, so there's not particularly an offset here. However, whenever I go to store in modes, I'm not copying every value, so there is going to need to be an offset there. What I recommend is creating an integer k, whatever you want to call it, that will track basically where to put the next value. Let's walk through this algorithm. I'm going to loop through counts. want to ask, is counts at I equal to my maximum? It is. So I want to get values at I and put it into modes at k, but only if that value, 13, is not already in modes. As we can see, 13 is not in modes. So I'm going to insert it here at k. Because I inserted an element, I'm going to increment k. That way I don't accidentally override it in the future. That is the end of the iteration, at which point I would increment. I'm going to get the current element from counts. It's a 1. I'm going to ask, is that equal to my max? It's not. So this iteration, nothing would happen. I would increment. I'm now at the 13. I'm going to get the current element from counts. It's a 3. I'm going to ask, is that equal to my max? It is. I want to take the current element from values, the corresponding element from values, and insert it into modes at k, but only if it's not already in modes. In this case, 13 is already there, so I'm not going to insert it. I would just let I naturally increment. We're now here. I'm going to get the current element from counts. It's a 3. I want to know, is that equal to my max? It is. I'm going to get the corresponding element from values. It's a 14. I want to insert it into modes at k, but only if it's not already in modes. In this case, it's not, so we'll insert, and because I did an insert, I'll increment k. I would increment. I'm going to get the current value from counts. It's a 3. It's equal to my max. So I'm going to get the corresponding element from values. It's a 13. I want to insert it into modes at k, but we see that 13 is already in our modes. So we don't, with it go on to the 16, and get the current element from counts. It's a 1. That's not equal to my max. This is a 3. It is equal to my max, so I try to get the corresponding element from values. It's a 14. I look to see that 14 is already in modes, so I'm not going to do anything with it. I'm here at the 21, or the 1. They align. I'm going to ask, is the 1, is the current element in counts equal to my max? It is not, so we're not going to do anything. I'm now here, and I'm going to ask, is the current element in counts equal to my max? It is. I'll get the corresponding element from values. It's a 14. I want to insert 14 into modes at k, but only if it's not already in modes. In this case, it is, so we're not going to do anything, and we would let I naturally increment. So when we finish, we're at this point. Now, a couple of methods that could help you. For one, to detect if an element is already in modes, we could use a couple of different methods. Contains is the one that I would roll with, because we just simply want to know, is 13 in modes? Is 14 in modes? Okay. Another one that you could potentially use is count. Right? I'm going to count how many times 13 appears. If it's a 0, I know it's not there. If it's any number other than 0, which will only be 1 if this is done correctly, then we know it is there. The last one that we wrote that could potentially help you is index of. Similar way, right? We'll do index of 13 in modes. See that we get a positive, or a number that is 0 or greater, something other than a -1, and know that it's there. This can function like a contains method. The cleanest one is contains, and that is what I recommend. So we're in this state. I'm basically done, except this is too long, right? If you look at our sample outputs here, we need them to be the exact length. And if we scroll all the way down to our final output, you see that I'm not kidding, right? It needs to be the exact length. In order to achieve that, the easiest thing you can possibly do is use Subarray. Recall that this functions like substring. We need 2 integers. Those are indexes or indices. The first one is inclusive. I'm going to start at index 0 inclusive. The second parameter, the second index, is exclusive, meaning it is not part of your actual output. So we're going to do 0 up to, and notice that this thing is still here, still sticking around, 0 up to k would give you a subarray. That would look something like this. And you see it is the exact size that we need it to be, the exact length. You would end up returning this final product. And that's how you do mode.